So this talk is going to be about telehealth platform. It's powered by Python and Django. It's a social network for doctors. Yeah, that's pretty cool. Yeah, so I can see your slides now. Remember, for everyone that is watching this talk, there is a Q&A button. You can click there and ask questions, and then at the end of the talk, I'm going to ask those questions to the speaker. So, okay, I think you're ready to go. Take over. Good luck. Thank you very much.
Hi. Today I'm going to talk about our telehealth solution, and it's based on a polyglot microservice architecture. And we use Python and Django. So it's a Python and Django powered AI platform. So what we have is a social network for doctors, a community where it's almost like a Facebook for doctors, where doctors can talk to each other. And also doctors can extend telehealth solution, right, as a what we call medical practice for their clinics or polyclinics to different patients. And especially in COVID scenarios, right, and this telehealth solution has become very popular, as you all know, and it's catching up. And the telehealth solution is being used in terms of not just for video consultation, but also for end-to-end, right? After the patient gets the prescription from the doctor, the patient takes the prescription, buys the medicines, right? Then the lab test needs to be done. He physically goes there, get the lab test done, and also the lab test get integrated into the system back. So when I say end-to-end, all the healthcare ecosystem players are being integrated in a particular solution. So that's the beauty of telehealth. That's become really popular. And we also see voice playing a big role in terms of being voice assistants, digital assistants helping out, right? And also in terms of helping out the doctors, you are having a clinical assistant, AI clinical assistant. So today we're going to look at what is the typical patient journey, right? And what do patient want, especially in this kind of scenario, and how does telehealth solution really help? And what's the telehealth platform? How does it look like? And how does semantic analysis help? There we talk about different patterns, voice assistants, right, and speech processing, and speaker recognition, speech types, speaker model, dialyzation, speech engine, speech analytics, digital assistant. How does it help in taking notes? And a little bit on the technical architecture. So looking at the solution. And what are the challenges which were faced, and a small demo I have, and what's next, and how do we go about enhancing the telehealth platform to next, and what's coming up in the technology trend in healthcare. So let's look at a patient journey. Right? The patient typically is having a fever, a cold, a cough, or some specific problem. He wants to book an appointment with the doctor. He books the appointment, and there's a appointment reminder, right, which is created, and you can have schedule being tracked, right, both for patients and doctors. And if there are any delays coming in from the doctor friend, you have the delays being intimated. If there are any changes, you go about managing the appointment, changing the appointment, rescheduling the appointments, and also after the appointment, if there are any follow-ups required, if you have post-appointment engagement. So a very simple patient journey. I think everybody is familiar with this, right? Many of the times people would have gone to a hospital, right? I mean, you have seen at the help desk, right, a receptionist, and you talk to them regarding appointment. So you envision yourself going into a hospital. Right? The same journey, you want to put that in an telehealth solution, right, on the cloud, on your mobile applications, web applications. And instead of receptionists, you take the same process, right, and have a digital assistant or a voice assistant help out in this particular process. Now, what do patients want? So let's take a step back from the technology. Typically, patients want a doctor to know him or her. And they want doctor to be competent. They want doctors to be caring about them and improving and curing and preventing their particular problems. Right? It can be your daughter, it can be your wife or yourself. This is what a patient typically wants from the doctor. So how does the telehealth solution help? Right? So from a technology point of view, we have a WebRTC based solution, right? And there's a deep learning based voice, and also a little bit on historical data, with patients' data, and predicting and identifying patterns. And we use neural network algorithms. And if you look at the solution, there are a lot of things which are happening, but there is a social community for doctors where we do take the feeds from internet data source and do the fact check, right? And have a CMS, right, like WordPress, and then publish blogs, publish feeds through mobile apps and web applications. And you have recommendation engine, cases, and knowledge engine, insights, and also a wallet and a payment gateway, just in case you want to have what you call payments to be processed for the appointments, doctor appointments. Right? And also you have transaction engine, loyalty management, curator. We are also enhancing for supporting IoT devices. That's another area which is evolving. The platform has support for voice, video, SMS, right? And also polls, surveys, and also insights. So if you look at the previous slide and current slide, and basically on the left hand right here, right, you have the historical data, the patient's data, the prediction and identifying pattern, which really helps for doctor to know the patients, right? And especially the voice assistants conversing with the user, right? Showing care, showing empathy, showing emotions, showing sentiments, right? That really helps in terms of substituting a digital assistant to a nurse or a doctor, right? So how does the telehealth platform look like, right, in terms of different components or different persons getting involved? You have users, you have groups, you have content, right? And we look at audio and video chats, which as an important component for telehealth platform. But you have notifications, you have discussions happening between the doctors, you have polls, you have social interactions, you have surveys, you have wallets, and also you have courses, events, news, career related for the doctors and medical students. And you bring in employees, nurses, and operational personnel, partners, vendors, and also customers, who are the users. And there are groups created within doctors where you can have moderation be done, or you can have group discussions, or you can have case triage where you, 2 or 3 doctors, right, discuss about the case. And you also can publish products, have product reviews taken from doctors and healthcare personnel. And there is content related to feeds, news, recommendations, and there are blogs and also services which are published to the content channel. The semantic analysis, like which I was talking about, where NLP plays a very important role. So that's one of the reasons why I added this session. Before we get into the NLP, the idea is to have understanding about the grammatical relationships between the words and phrases. Right? So natural language processing, which hits upon this. You have blogs, news, feeds, right? So there's a lot of text mining and text processing which happens behind, right? Especially in the voice assistant or digital notes, right? Or prescriptions. Right? And if you look at, I'm just giving a very simple example, right? John hit the ball. Right? You have subject, verb, modifier, and an object, and you are trying to identify what are the entities here, right? What are the verbs here? What are the nouns here? Simple noun-verb analysis helps. Or you do entity extraction, right? Or parts of speech extraction, and you try to identify the nouns and also sentiments. Is he talking about the ball being hit really hard, or let's say John got hurt, right? Was the injury bad? So if you look at these particular adjectives, you get the positive or negative sentiments. Like typically, you look at words like good, great, fantastic, excellent, friendly, right? Awesome, spectacular, And we something negative, right? He got hit badly. It was a worse shot. Right? And there was an issue here. There was something loss, an awful problem, bogus. So these are all negative sentiments. Now, like semantic analysis, the other key section is patterns. Right? We identify patterns in the historical data. So what has happened before in a patient's life? What I have seen before? Right? We also look at demography. We also look at appearance, sounds, physical signs, smell, touch, feel, images, fluids, tissues. Right? All these are different areas where patterns do the analysis. And there's also mining, data mining, which happens in the notes or in the prescription, right? Or in the speech. When the patient is talking over to the doctor, there is a lot of discussion which happens, and the patient tries to explain his physical condition or his disease condition, and that's where, right, all the patterns analysis really helps. Now we jump into voice assistants, and now we have understood the semantic analysis and the patterns. So a simple voice assistant, like let's say it's on the Google Dialog flow, right? And you want to look at the doctor looking at the patient's report, and he wants to look at a patient, right? He sends a request, and Dialog flow processes that particular simple command, voice command, and sends the response back and shows the generator report saying that these are the list of patients. Now, similarly, a patient talking to a voice assistant is slightly complex, wants to know about COVID-19. Okay? So the Google Dialog Flow provides capabilities like keywords, right? Keyword search, like for example, COVID, right? Or how does COVID affect the pets? Right? Is having pets a bad situation during COVID, or do you have vaccines for COVID? Do you have any medicines already identified? How do you go about preventing COVID? So all these are simple voice commands being like a keywords being sent as a request, and Google Dialog Flow tries to process them and sends the response back. Now, how does the whole speech processing work? Well, let's take a step back from AI and look at the speech processing. Right? So you look at speech coding. So when the speech coding involves synthesis and recognition, you also have a speaker model. The speaker model consists of speaker identity and speech transcription. The speech transcription basically is converting speech to text. Speaker identity is basically the speaker profile. Who is the speaker? Right? Where is he from? Which language he is talking? What is his accent? These are all demographics, right? And these are all play a very important role in terms of creating a speaker model. Similarly, speech type. You have speech patterns. You have dialyzation, which is also very important. Speech patterns there are many ways of saying the same thing. Right? In a hurry, we show emotions. Right? When you're presenting formally, right, the speech pattern might be very different. Where when you're informal, it might be completely different from the formal. Then, given these challenges, right, where there's speaker identity, accent, languages, and speech patterns, how do you go about recognizing the speech? There are various approaches. You have template-based word recognition, continuous speech recognition, neural network-based recognition. You typically have a template saying that it's going to be very structured, where I have an agenda. I talk about what, when, how, and last I talk about what is next, right? And then present. So it's very, very structured, and you know what is going to come. Then the recognition becomes much simpler. Let's say it's a continuous speech, like what we are discussing now, when we are brainstorming. There'll be a lot of question and answers will be there. It's continuous. The neural network-based recognition is basically the next level. Right? It's not just template or continuous. The neural network has capability of learning. Right? So you have feature extraction, speech direction, vocabulary, and knowledge-based acoustic model, right? And you have analysis and feature extraction modeling and testing, which is done to improve the neural network model. Now, what are the speech types? In a speech, you have isolated words, you have connected words, You have spontaneous speech. Well, let's take a simple sentence. John is going to fall. So when I say John is going to fall, right? You see there are words which are broken. John is going to fall. Let's take a complex sentence. Although John was wealthy, right, he was very modest. Now you see in this particular speech, especially after although, right? You see a pause, then John was wealthy, then you say he was modest. So there are connected words, there are isolated words, broken words, and there is a spontaneous speech. There are multiple types of speech which needs to be handled. So what are the different speaker models? We talked about speaker identity. Now let's look at speaker model where there's independent speaker model, right? Say especially on Zoom, you're seeing at the bottom, right? It's able to create subtitles. It's independent of who the speaker is. It doesn't know where I am from. And in EuroPython, there will be speakers coming from various countries, right? And it can detect. So this model is basically independent. It is able to detect the speech and then turn it into subtitles. Whereas you look at dependent model, it's very specific to a particular speaker. And that particular speaker knows my identity, right? My background, demographics. And there's a neural network engine which keeps on working in enhancing the capabilities. Now, what is dialyzation? The dialyzation is, if you look at speech being represented on a graphical node, you see most of the time, right? You record your speech, there will be almost like a waveform where you see a cluster of, right? Cluster of waves with higher wavelength versus others which are wide with a lower wavelength. Now, and you break those down into different segments where there are broken what you call waves or there are pauses. Take those each segment, right? Translate that speech to text. You get the transcription done. So that is dialyzation, right? Now, if you look at speech engine, now you looked at the various components of the speech processing. Right? Now, if you look at speech engine, you have audio, and you have what you call the grammars and acoustic model and Ignatz test, and you have environment which is around, and the channel, speaker, and you have style, gender, age, and speech speed. And depending on the demographics, right, speech speed varies. Some people talk very fast, some people talk very slow. But a speech engine needs to have capability to handle both of them. How about speech analytics? So while doing the speech processing, you prefer to look at emotions. You need to look at periods of silence and also non-speech. Like for example, oh, I think I'm in the middle of a meeting, and I start thinking that I think I need to start looking at the time also, right? Or let me take a step back and think about it. And I pause. Do you see the pause there? So even though it's a very simple sentence, basically, I need to look at the time, and then I'm in the middle of this particular session. It looks very fast, but but this particular segment, you break it down into different segments, you see non-speech areas. So speech analytics processes what are the periods of silence, right? What are the non-speech areas, and what are the emotions detected. Now let's look at digital assistants. Having looked at the speech recognition, speech processing, how does the speech processing really help in digital assistants or voice assistants? Now let's start looking at digital assistants. This is where NLP and semantic analysis plays an important role. It helps in taking clinical notes, retrieving cases, processing commands, processing sometimes speech, voice commands, updating prescriptions, creating consultation appointments. Now, let's look at the technical architecture where you have voice assistants, digital assistants. That's where the speech processing, the speech engine, speech types, really help. And these are all helped out. These are all being processed in the Google Dialogflow. So using IBM Watson helps out, which is in terms of the speech processing capabilities, and then supports them on IBM Lumens. So from the technical architecture point of view, the telehealth platform which we built has Android, iOS, mobile clients. It also has services layer built on Python, Django, PHP, Java, and we have MySQL and MongoDB as the database. MySQL is for relational, and MongoDB is for NoSQL as a NoSQL database. Now, what are the challenges in building this particular platform? So especially when you are building voice assistants, digital assistants, or a video platform, you need to look at the browser's capability. You need to look at the mobile OS dependency, right? You have desktop OS issues. You have speech hardware issues, right? I don't know how many attendees had problems. Typically, right, when you get into any conferencing system, most of the time you have challenges with the speech hardware. It depends on whether you are using Windows 10, Mac OS. Right? It's just the incompatibility or the drivers which are challenging. Sometimes desktop OS. Sometimes if you're, let's say, connected to this conference through mobile OS, the mobile OS has challenges in terms of providing the audio and video capabilities. So now let's look at the demo. So I have the so here I'm signing up. So I have the MySQL started. I've started the Python Django server. Now I'm signing up. This is the doctor who's signing up. I just put the doctor's name as Dr. John. So now I log in after registration. So this has feeds. Now let's look into the voice assistant. So I say hi and try to start the recognition process. I said hello. It started detecting hello. Now I send the command hello. So it comes back with the response. Now I started looking at Corona. It detected Corona. Now I'm sending that message. I got the response. So that was about the voice assistant. Now let's look at the clinical assistant, right? Now you're a doctor and you talk to a patient and you want to. So he has fever and I have recommended paracetamol and I'm taking that notes. Now I want to have a video appointment with the doctor. So I started the video. Now let's look at the other side. There's a patient who wants to connect to the video system. Now here I am registering as a patient. Now go to the register. So now I'm a patient now. Patient.gmail.com. So I'm just simulating both at the doctor and a patient for the demo. Now I log in as patient@gmail.com. Now I go to video over here and you see the person logging in. Right? And you see the person trying to call. And now the connection gets established after accepting. So when I go back over here as a doctor, I completed the video session and I log out on both sides. So that was the demo. We looked at demo which was powered through Python Django AI platform. It has MySQL and HTML5, and I used the WebRTC for the telehealth and Google Dialogflow for digital and voice assistants. Now, many people ask, I see customers and I see in the conferences, Bhagwan, you talked about voice assistants, digital assistants, telehealth solution. What is next? What's next in the technology front, right? And especially in healthcare or in any domain with respect to AI. So one of the things which are evolving is the biometrics, right? And other area is the language, another dimension, right? And we look at English, and we have people coming in from joining EuroPython from Dublin, Amsterdam, France, and many countries, right? Can I talk in French? And can we have doctor and patient relationship, doctor being French and patient kind of talk being in India, right? Can you have multilingual speech? And similarly, can you have knowledge assistant which is learning, has capability of self-learning, which is able to update itself? And also, can you have a connected system? It's not just an isolated system, but like we talked about pharmacy and labs, diagnostics, and pathology, and clinics being connected, hospitals being connected. Can we have all systems being connected, integration possible? I think that's the next level. Now we go to the next, higher level where we want to have dynamic program creation. Can we have a program being created with AI? Right? Can you have AI coder who can create a program? Right? Before, normally we have code, we used to have code generator. Now AI coder is intelligent in terms of having a neural network based support where you have neural sketch for different technology stacks. And a neural sketch has capability of understanding the technology stack, breaking down into various layers, what is required for each and every layer, right? What is the domain, and what is the domain model, what are the entities, what are the services, right? And also what is the workflow created, how does the process look like? Now, next level from AI coder is, what if I don't want the AI coder? I would just want to, I'm a business user, I'm aware of the process, I'm aware of the domain, I'm aware of the process steps in the workflow, and you have various users logging in and interacting at the process activity level. Can I have a no-code automation platform where you can drag and drop and create a process and it deploys it on the cloud, right, without any code being created? Answer is yes, and that's the no-code automation platform which is upcoming. So that was a brief presentation about telehealth polyglot microservices platform. So any questions, any thoughts, ideas? There was one question regarding mobile app available on Play Store. Yes, we have the mobile app available. It's called White Codes. We have both network app and also the telehealth app for many of the doctors. We also have a Clinic Plus mobile app which is available. We also have a white label mobile app for your clinic. So we have doctors community around 400K, and the doctors, we have nurses and medical professionals who use our system. Any other questions? Regarding the licensing model, the Doctors app, which is the network app where we have a social community, there's no licensing. It's what you call, you're a doctor, you validate yourself with your medical certificate. Regarding the payment model for the Practice Plus front, there are multiple packages which are available. Like if you go for web model, or if you go for mobile app model, or if you go for white labeled app for your polyclinic or clinic, there are various packages which are available online. If you see the website, and it's called Practice Plus Suite, and we have multiple packages available. Can you, as a patient, just log on and see any doctor that uses the platform, or do you have to request a specific doctor? This is a good question. So in our platform, we have doctors who refer our patients, and the patients will be able to go to a specific app on the Play Store, install the app specific to that particular doctor.
Okay. So any other questions? I think, oh, there's more. So people is asking about
What about data privacy? Yeah, that's a very good question. And we look at data privacy very carefully because there are a lot of guidelines which are coming from telehealth, and we also follow HIPAA standards. And also in terms of the data exchange, we follow HL7 and here FHIR support we have. So we take data privacy very seriously, especially in terms of the patient's data and doctor's information.
Okay. So we still have a few minutes, but
in how many countries is it used? Currently, we are supporting within India, so we have plans to go take it to the other countries. So regarding the other countries, the challenge is, as you know, right, one is the telehealth guidelines that country supports. So we are looking at various countries within Asia.
Okay, perfect. So I think there's no more questions. So I'm going to say thank you very much for presenting an EuroPython. Going to play some, so you have some people clapping for you. Okay, thank you very much. That was really good. There is a channel in Discord, so the name of the channel is Talk Telehealth. So if someone wants to continue the discussion, you can join that channel there. It's in Discord. You have to go to the Brian breakouts, and then you have the Discord channel for each talk, and you can continue the discussion there. Or if anyone has more questions or they want to understand more about the project. Okay, so I think that's all.
Thank you. Thanks, sir, for giving an opportunity to talk about telehealth platform.
Thank you for presenting. Speakers are the most important part of a conference. So thank you very much. Have a good day. And yeah, see you next time.
Thank you, Bhagvan.
Bravo.